Hey, good day, students and teachers. Welcome back to my YouTube channel. As promised in my last video, I said that we're going to be working on further explanations on gas laws. So today we're going to be working on pressure law and general gas laws.
Pressure law states that the pressure of a given mass of gas is directly proportional to the absolute temperature, provided that the volume is kept constant. So mathematically, this is represented as pressure is directly proportional to the temperature. That is, pressure equals the constant, the temperature and the constant volume. Then pressure over the temperature equals the volume. That is, the initial pressure over the initial temperature equals the final pressure over the final temperature. Then to find the values of the x, y, z, pressure x, temperature y, and the volume z, like we've done before, that is, the P over T equals volume, then P with the power 1, T taken up turns to minus 1, and V with the power 0, then P with the power 1, T with the power minus 1, all over V with the power 0 equals 0, and P with the power 1, T with the power minus 1, V with the power 0 equals 0. Therefore, our x, y, z values equals 1, minus 1, and 0. We should note that when this constant goes up, the zero power is minus 0, but because both minus 0 and plus 0 are all the same thing, so that's why it's just 0. The general gas laws. The general gas law is basically, it's the combination of the Boyle's law, the Charles law, and the pressure law. That's what results in the general gas law for ideal gas. And the general gas law, that is, combining the three laws we've done so far, is PV is inversely proportional to the temperature. No, is directly proportional to the temperature. Sorry. Pressure and volume is directly proportional to the temperature. So that is PV over T is equals to constant. P, the initial pressure, multiply the initial volume all over the initial temperature equals the final pressure multiply the final volume all over the final temperature. So like we've done so far, our Px, Vy, and Tz in this situation is PV over T, that is the P with the power 1, the V with the power 1, and the T when it goes up to the power minus 1. Therefore, our X, Y, and Z equals 1, 1, and minus 1. So we've come to the end of the introduction or explanation of the gas laws, and next we are going to be working on on just 2 examples each under each law. So using our formula, P over T equals constant V, initial pressure over initial temperature equals final pressure over final temperature. So our parameter says P1 equals the total pressure actually equals 1007 millimeter mercury. So the total pressure minus the pressure given at 77 degrees Celsius equals, that's 1007 minus 314 equals 693 millimeter mercury. So that's our pressure 1, our P1, 693 millimeter mercury. Then our T1, 77 degrees Celsius, converting to Kelvin, that's plus 273 Kelvin equals 77 plus 273, 350 Kelvin. So our second pressure is unknown, and our final temperature is 27 degrees Celsius. So that is 27 degrees Celsius plus 273 Kelvin equals 27 plus 273, 300 Kelvin. Alright. So P1 over T1 equals P2 over T2, making our final pressure subject to formula crossing P1 T1 equals P2 T1 equals P1 T2. That is our initial pressure multiply our final temperature all over our initial temperature. Please don't mind my camera. I hope you can see. Okay, so our final pressure equals our values. The first one, 693 millimeter mercury, so that's 693 multiply our final temperature 300 all over our first temperature 350 Kelvin. That is 693 times 300 equals 207,900 divided by 350 equals 594. So that's 594 millimeter mercury. So moving on to general gas law. We'll be taking our final example on this topic. Question 1. Okay, so for general gas law, our question is: the volume and pressure of a given mass of gas at 27 degrees Celsius are 76 centimeter cube and 80 centimeter cube. 80 centimeter of mercury. That's our 80 centimeter mercury, respectively. Calculate its volume at standard temperature and pressure. STP means standard temperature and pressure. Okay, solution. So our formula for general gas laws is PV all over T equals constant. So that T is our initial pressure multiplied our initial volume all over our initial temperature equals our final pressure, final volume all over our final temperature. So our parameters is moving on. So our V2 equals inserting the values. Our V1 is our P1 pressure 1 is 80, multiply our V1 76, multiply our T2, that is 273, all of our P2 760 millimeter cube. Our P2, since our pressure, our initial pressure is in centimeter mercury, we are going to convert our millimeter mercury to centimeter, which is 760 divided by 10. That is 76 centimeter mercury. So here we're using 76 as well. Multiply our T1, that is 300 Kelvin, equals 1,659,840 divided by our 76 multiply 300, 22,800. So equals 72.8 centimeter cube. Our final volume equals 72.8